Welcome to the decorators section of the course. A decorator enhances a function with additional features without changing its core functionality. But before we get into that complexity, we have to dive into some advanced features of Python. So some parts of this section will be general review, while some of it will be brand new. And let's begin in this lesson by talking about higher order functions. A higher order function is one that either accepts a function as an argument or returns a function as a return value. Now, this can be a particularly confusing concept when you first hear it. A function is just a sequence of steps to us. It's a bunch of instructions in order. It seems like a bit of an abstract idea, not like some kind of data structure. However, remember that everything in Python is an object, and that includes functions. A function is an object. And we can prove this by passing in a sample function into something like the built-in type function. So for example, if I define a very stupid 1 function that simply returns the value 1, what I can do below is do print and pass in the invocation of Python's built-in type function, and to here, I'm going to pass in the function 1. Notice that I'm not passing in 1 invoked, because if I actually invoke it with parentheses, it's going to return the number 1, and I'm going to ask for the type of 1, which is an integer. I don't want the type of the return value. I want Python to tell me what this thing is. What kind of type is it? What is it made from? And if I execute this, we'll see that it's made from the class or the blueprint called function. The point being that this is an example of a object or a data structure in a language made from this blueprint called function. So this thing right here on lines 1 and 2, the functions that we've been defining for the entire course are examples of objects. A function is an object. And as we talked about, this idea of a higher order function is one that accepts a function as an argument. And believe it or not, we're seeing an example of that in action. In this example, type is actually an example of a higher order function. Because think about it, it is accepting another function, 1, as an argument. We're not passing in 1 invoked, we're passing in just 1, the function. So type in this case is acting as a higher order function. And what does this mean for us? Why is this important? Well, what it means is that functions are just like any other object, and they're going to have similar functionality. So anything that you can do with a string, a number, a list, a dictionary, a tuple, etc., you can also do with a function. So if, for example, a function can accept a number as an argument, well, then a function can also accept another function as an argument. If a function can return a number, it can also return a function. If a list can store a Boolean, well, then a list can also store a function. If a dictionary key can store a value of a string, well, then a dictionary key can also store a value of a function, etc. So the way I want you to think about it is wherever I can use a number or anything else in Python, realize that you can also use a function in that place. And again, we're not just talking about the return value of an invoked function, we are talking about the uninvoked function itself, the collection of logic, the sequence of steps. So let's begin with a simple example to get our feet wet. Below here, I'm going to define 2 basic functions, add and subtract. They're both going to take 2 parameters called a and b, and they're going to do exactly what you expect. Add is going to return a plus b, while my subtract function is going to take a and b and return their difference. Here's where things are going to get super interesting. The next thing I'm going to do is define a function called calculate. And I'm also going to give calculate the same parameters of a and b, but I'm also going to precede them with a third parameter, which I'll call func. F-U-N-C in this case. Now func, just like any parameter name, is just my own chosen parameter name. It is up to me, it is up to the developer, but the name reflects the idea that I expect this argument to be a function of some sort. Okay, I'm not necessarily sure what it's going to be just yet, but I want it to be a function, and func is a good descriptive name to describe that. So what I'm going to do in the body of calculate is do this. Think about it. I expect that func is going to represent a passed-in, uninvoked function. It's important to recognize, again, this is not the return value of a function, it is just the function itself. So if we have func representing a function, any function, we can invoke it in the body of calculate like so. Just take func, and we know our invocation syntax is parentheses. Then what I'm going to do is take a and b, which are going to be my second and third arguments, and I'm simply going to pass them in as the arguments to the invoked func that is passed in, whatever it may be. Now, func is going to process its own logic using the arguments of a and b, and it's going to return it, but it's not necessarily going to represent the return value of my calculate function. So in order to take what I have on line number 13 and actually make it the return value of calculate, I also have to make sure I return out of calculate whatever it is that the func returns when invoked. So what's this going to look like in action? Well, let's take a look. Below here, I'm going to invoke my print function. I'm going to pass in calculate, open my parentheses, and here it expects to get a func. Remember, this has to be a function. Well, we have two wonderful functions sitting above. We have add and subtract. So let's go ahead and pass an add. So I'm literally going to write add. I'm not going to invoke it because I don't want the return value of add. I want to pass in the actual function itself, this recipe, if you will, this cooking recipe, this set of steps or instructions for doing an operation called add. Then I'm going to provide two sample arguments. Let's do 3 and 5. So these are going to represent my values for A and B respectively. And now we can obviously predict what we're going to see on the right. It's going to be the addition of 3 and 5. In fact, let me show you. There it is. We're going to see 8. But let's talk slowly through what happened here. So I passed in a function called add, and it was represented by my func parameter right here. And what I did with that func argument right here on line 13 is invoke it. So right here on line 13 is where Python actually invoked add. And to add, it passed in whatever I passed in as A and B, 3 and 5. So when Python was running line number 13 and saw this, it then ran lines number 6 and 7. It did the math right here. It got 8, and 8 was the return value of func, which was add, when invoked. And once I got the number 8, I made sure to return 8 out of calculate. So that's what we see right here on the right-hand side. And you might be able to guess exactly how this might work with another functions. What I can do is, again, invoke calculate. And now, instead of passing an add, I can pass in an alternate function, such as subtract. Again, simply passing in the name of the function, nothing more. Let's go ahead and subtract 10 and 4, so 10 minus 4. Execute this. We're going to see 6 on the right-hand side. And again, just to walk you through what happened, we passed in subtract as our func this time around. It's a dynamic argument that can really represent any function technically. And so we took whatever function was passed in, which was subtract. We invoked it here on line number 13, passing in 10 and 4. Python ran this. It calculated 6 and returned that. Once we got the 6 here, we made sure to return it out of calculate. So the calculate final return value is 6. But the key idea here, of course, is that we are able to pass in functions as arguments. And that's an example of a higher order function, or in this case, calculate is the example of a higher order function. It is a function that accepts another function as an argument. In this case, the function that it accepts as an argument that is passed in, we gave the parameter name func, right? But the whole idea is, and tying back to what we talked about, just like A and B represent numbers and they can represent any other data type, we can pass in functions as arguments, right? Because if you just think of functions as any other data type in Python, it makes sense because anything that you can do with a number, you can literally do with a function. So right now, obviously, you might be looking at this and saying, okay, but that's a really complex way to add and subtract. What's the point of this? Well, these are all critical fundamental concepts that we're going to need to understand in order to later understand the idea of decorators. So this lesson and the next couple lessons are sort of going to be a little bit of a warm-up, a little bit of a review, and a little bit of an expansion of the ideas that we've talked about before. And all of these lessons are going to build up to the introduction of decorators, which are one of the most advanced but also special and powerful features of Python. So once again, there is a ton to cover in this section, but I am excited to take you all through it, and I will see you in the next lesson.